Okay, how many positive integers less than 1,000 are trifactorable? This is kind of like you can do a guess and check thing. You first have to understand, like you've never seen the word, but you have to kind of get a sense of what a trifactorable integer is. So for example, is 6 trifactorable? Right? It is, because it's 1 times 2 times 3, right? Is, and first it's saying consecutive integers, so you can't do 2, 4, and 8. It says positive integers, right? Because 0 is trifactorable, right? A few negative numbers are trifactorable because negative times negative times negative is negative. So you can start with 1. You can do 1, 2, 3, and 2, 3, 4, 3, 4, 5. Just keep going until you realize where do you stop. Like what is the highest trifactorable? It's under 1,000. So you realize quickly that what's 10 times 10 times 10? That's 1,000, right? So you know 9, 10, 11 is, well, first of all, what's 10, 11, 12 is too big, right? If 10, 10, 10 is 1,000, 10 times 11 times 12 is too big. How about 9 times 10 times 11? That works, right? That's 990. So you know the upper bound is 990. You know the lower bound is 6. You realize it's 1, 2, 3, 2, 3, 4. I would actually just write it out, like what you did actually here. This looks like my test, like what I would have done. You don't actually, I guess you had extra time, so you actually solve for all the trifactor, which is good. Now you know. But it's good. If you have extra time, do it. Like you have to keep yourself. Like that's the thing. Like some people take naps in between this stuff, but like you go double check. You've double checked enough. You're tired. Just like keep your mind active, right? So he actually counted it out, which is good. I recommend it because you could just mess up by mistake. This is a very prone to silly error kind of problem. I forget one. So it was 9. Okay. 17. And this one is a word problem. You ever?
I had a question on 16. I actually misread it when I saw it, and I thought it was saying how many like perfect cubes are there.
Oh,
but
yeah.
it turns out that they're the same number of perfect cubes.
Under.
Oh,
Oh, really?
That's
funny.
The product of 3 consecutive integers.
That's funny.
I don't know if that would be relating, because if they're consecutive, I mean,
It's close. It's kind of close, right?
Yeah.
But you guys realize that like, if 10 times 10 times 10 is 1,000, but then 9 times 10 times 11 is less than that. Like that's like a number theory realization that you hopefully like inculcate. I don't like. It's not necessary, but it's the same reason why a square. It's the same reason that if you had a certain length of fence, certain budget for fence, and you wanted to maximize the area you could build, you always build it in a square and not a rectangle, right? Because say you had 25 feet maximum for. It sounds like a math problem. It is a math problem, but like I guess you could actually use it. Say you had 25 feet of fence, a square would be, 20 feet. Sorry, 5 and 5. So the area is 25. Or you could make it a rectangle versus 4 and 6, and that's 24, right? Closer two numbers are together. I don't know how to word this, but it's just a realization you get. And this is something that also could be on the SAT, where it says, this is something that would definitely be on the SAT too, where it says like, it's an optimization problem, and once you take calculus, this is like the easiest thing. So 17 is a word problem. Set her up. Again, we'll go through it. Just somebody give me like how to set up the first sentence in terms of variables. It's the same technique for all these word problems. I don't want to call anyone out like to have them do it, because I hate it when even in college I was called out like in that crazy professor class. I didn't know. Nobody around me knew, but like there were a few who did. A few really smart kids who did know. And it's like it's not a good feeling. It kind of turns you off. So I don't want to I'm sure some of you missed this. I don't want to say solve it, right? I can do it. But I trust that you will solve it, right? Or if you don't get it, just take notes and solve it. So the first thing, did you get this wrong? Yeah. Oh, okay. So yeah, well, I'm just using yours as an answer key actually. Yeah, so the first sentence, how do we convert that into like numbers and words, and numbers and variables?
1 plus 0.07 times x minus 20 in parentheses. Or no?
1 plus, sorry, just look at the first.
That's what I did. I got the answer.
I did too, but I didn't see the equation when I was doing it.
Oh.
I worked them all out. It's so much easier when you look at it now.
Yeah.
It's like,
What was I thinking?
One thing that simplifies this is to do it in terms of pennies instead of dollars. That helps a little bit.
Oh, yeah, yeah, so, yeah, so they'll give you like 0.07 times x, that's often easier as 7 times x, right? So first, if we convert it to pennies, right, let's make it 100, that's a fixed cost, plus, plus 7 times x minus 20, where x is greater than 20. Yeah, x has to be greater than, like, and then you write that, that's right what you said. So let's just say the first carrier A, we'll say the variable, the equation is 100 plus 7 times x minus 20, where x is greater than or equal to 20, right? So that means that, or t, why are we using t, x? T is time in minutes. So 20, like say, you can't plug in 5 minutes because then you get a negative answer. So this is where the intuition comes in. You realize this is an equation with a parameter. The parameter is that the only t's you can plug in are greater than or equal to 20. So a 25-minute conversation is how much? How much would it cost? 135. So $1.35. Yeah. How about for carrier B? What would that be?
60.
60. Now it's saying, recall that last t minutes, the cost of using carrier A is the same as the cost of using carrier B. T is a positive integer greater than 20. What is the value of t? So you set it up right. Or no, actually no you didn't. Well, close though. T is a positive integer greater than 20. Right, so this is, now you just set these equal to each other, right? I'm going to expand it already, right? Minus 140 equals 60. And what do you get? What's t?
40.
40. Right? Because you just, subtract 60 there and put other stuff there and you get 40. And then you can check, right? How much did they actually spend? And does it add up for carrier A and B? So carrier A, how much did they spend?
They spent $2.40.
Right, and carrier B?
Same thing.
Right, yeah. I mean, you should know it'll be the same thing, but you should check it, right, to make sure A and B is right. Cool. 18. Cool. So you can label the figure first, right? It already tells you what the side length is. How many squares are in this figure?
10.
10. 4 plus, which again is 1 plus 2 plus 3 plus 4 squares, right? Which, what was the formula
I didn't tell
to,
you that.
what was the formula we did for like the 1 plus 2 plus 3 plus,
N times n minus 1 over 2. Or n plus 1, sorry.
and so we went up to 4. What is that?
20 divided by 2 is 10.
Right, so just 10 squares. I'm just trying to show you it works. Hope you can just see those 10 squares there. So 10 squares, what is the area? What would the area be in terms of K?
The area is 10 squared.
10K squared. 10K squared, right?
Yeah.
So A equals 10K squared.
Is there a light flashing?
And here you literally just count around, you count all the solid black lines and figure out what the perimeter is in terms of K. What is that?
16.
16? Okay, I didn't count it. So P equals 16K
That's what I did.
and A equals P. Right, so you got 10K squared equals 16k. 1k cancels, right? That means k could equal 0, by the way. If you cancel out a k, if you can cancel the k out, that means that 0 is a solution. Right, because that makes sense, because if you plug in 0 for k, that becomes 0 and that becomes 0. Right, you don't want to forget that. A lot of people forget that when they cancel the k out, they lose a solution immediately. Luckily, 0 doesn't make sense in this case, right? So we can just cancel it out. So 10k equals 16, k equals 8 over 5. Which, what's that in decimal form?
1/6.
1 for 6, nice. No calculator. So I think the key thing here was just realizing like what they were asking. Being able to see that you can count, you don't want to count all the lines, you just want to count the solid lines for the perimeter. Cool. Were there any other questions in this section?